Hey there, this is Professor Bahara. I'm speaking from Accurate Physics. If you haven't subscribed to this channel, please subscribe this channel right away. I will be coming with more interesting videos related to physics questions and physics teaching. So in today's talk, I'm gonna talk about backward design, what this is. So this will be very interesting talk if you are instructing, if you are teaching physics, if you are professor, college professor, university professor, or even school professor, this video is for you. Please keep watching this video. And this video is equally important for students who are enrolled in college or university, because once you understand the teaching, you can understand the material when your professor is teaching in your classroom. That's why this video is very, very, very important for teachers, professors, and students of physics, and it should also be relevant for other discipline because teaching is basically same. So to get started with the actual material, let me start what is backward design. So backward design means, as name suggested, we have to move backward. So in your classroom, what do you want to achieve your students? What students should get at the end of the semester, at the end of the course? So they should understand the learning outcomes, right? So there are certain learning outcomes from particular course, what you are teaching. In this case, I'm talking about physics. This particular example is related to physics. So I will talk for physics, but this example will be equally applicable in other disciplines in STEAM like chemistry, biology, mathematics, nursing, or computer science, whatever, and beyond. So that's why this will be very, very interesting. So there are so many components. There are so many steps to be completed by students to achieve the end results, right? The learning outcomes. So by the end of this course, what students should get, what students should learn, what students should understand, that is the learning outcome. But as a professor, you should start when you are preparing for the class, when you are trying to teach your class. Don't start with content or learning activities or assignment. You should start from the learning outcomes and then move backward. For example, when I illustrate with best example, you will be understanding much better and better. So if you are teaching physics or any other discipline, please keep watching this video until the end. Okay, so look at here. So I'm modeling backward design for particular topic of the physics. So you can do as a whole for entire course, right? So first thing is, what is your learning as a learning outcomes, learning objectives? By the end of the course, what you want your students to know. So for example, by teaching certain portion of my physics course, I would like to know, I would like my students to learn or illustrate Newton's laws of motion and their application. So this is learning outcome, learning objective from my course, from particular topic, right? It could be under Newton's laws of motion, of course, right? So my objective here is illustrate Newton's laws of motion and their application. When you are designing learning objectives, read the active verb, pay attention to the active verb, illustrate. So I'm not planning, or I'm not thinking about illustration, I mean discussion or definition, something like that, right? my goal is my students should achieve, my students should be able to illustrate Newton's laws of motion. So there are three laws of motion, right? They should be able to illustrate three Newton's laws of motion. So this is my learning outcome, right? So keeping this end in mind, so this is the end product, right, of my teaching. I should come backward. So this is my learning outcome, illustrate Newton's laws of motion and their applications as well, not only laws, right? And then I have to move backward, first write down my learning objectives, then come to the assignments. So to achieve this goal, illustrating Newton's three laws of motion and their application, what assignment is relevant? It should be some hands-on activities, that is something related to lab, related to Newton's laws of motion, right? So my assignment will be lab reports on Newton's laws of motion, first law, second law, and the third law, right? So if my learning outcome is something like discuss the Newton's laws of motion, I don't need lab, right? Because I don't need something like illustration. They just have to understand the basics of Newton's laws of motion. They should be able to discuss on it and can say definition of the Newton's laws of motion. That's all, right? I can just coin some other kind of assignments like discussions or something like quizzes, right? But in this learning outcome, my outcome is illustrated. That's why lab reports or lab, some kind of lab or some kind of hands-on activities that illustrates Newton's three laws of motion, that is my assignments, right? So this is the backward design. I'm coming from learning outcome to the assignment. Then what kind of learning activities students will be doing? So assignment parts, I'm designing. Learning outcomes, I'm designing these learning objectives, right? But these learning activities, I'm designing, but students are trying to do activities. They are actually doing activities to achieve their goal, right? So I have to provide the activity. I have to facilitate the activities to achieve this goal, right? So what should be the activities related to Newton's laws of motion? To illustrate Newton's laws of motion, read lab manual. I should provide some material so that students can do some hands-on activities, lab activities. So I'll provide a lab manual and students will engage in reading the lab manual and perform experiment. And experiment is of course related to Newton's laws of motion, Newton's first law of motion, Newton's second law of motion, Newton's third law of motion. Might be I'm providing some balloon and they will blow it off and they will turn down this mouth downwards, and when they release the air from the balloon, then balloon will go up and air will go down. So that illustrates Newton's third law of motion, right? It's quite simple, but it, it should be something related to my outcome. So this is the learning activity I will be providing. They will be reading the manual in which they will learn about Newton's three laws of motion. In concept, they will get concept from the reading of the three laws, and there are a few questions so that they can apply those law in particular situations, and they will be doing some activities related to first law, second law, and third law. So these are the activities the students or my students will be doing in my class, right? So what contain? So these are the activities, right? First, I have to go back to the content. I'm moving backward. That's why this is backward design again, right? So I need to provide some content like lab manual is the content, right? With laws of physics, Newton's laws of motion, with data table, because, data will When they do activities, they gather data, they calculate, and they will actually illustrate Newton's laws, right? There might be some questions so that they can apply the associations Newton's three laws of motion in actual scenario. So that should be the content. So look at here. Actually, the starting point is content. Then we will do the learning activities and then provide assignments, and finally we'll be achieving our goal. But as an instructor, as a professor, I should think and in the mind at the beginning of the semester, very beginning of the class, right? Learning outcome. Then I have to design assignment. Then I have to design learning activity. What students should do to achieve those goals that I'm planning to get it, out of my teaching, right? And then provide the content. So everything is aligned, right? Everything is in single line. Everything means content, learning activities, assignment, and learning outcomes. So I'll be coming with more interesting videos related to physics concept, physics questions, and physics instruction, physics teaching. Please subscribe this channel. Thank you.